Today we will be learning about calorimetry.
Calorimetry is the measurement of heat flow, and heat flow is measured using a calorimeter. The heat capacity of an object is the amount of heat required to raise its temperature by 1 Kelvin or 1 degree Celsius. It is symbolized with the letter C. If you think about it, the greater the heat capacity, the greater the amount of heat needed to produce an increase in temperature. The molar heat capacity of an object is the amount of energy needed to raise the temperature of 1 mole of it by 1 Kelvin or 1 degree Celsius. It may be symbolized with C of M. Specific heat capacity of an object is the amount of energy needed to raise the temperature of 1 gram of a substance by 1 Kelvin or 1 degree Celsius. It may be symbolized with C of S. Specific heat can be determined by dividing the quantity of heat transferred by the product of the grams of the substance and the temperature change, with variables that can be written as C is equal to Q over M times delta T, which can also be arranged as Q is equal to MC delta T. Now let's do an example problem. How much heat is needed to warm up 400 grams of water at 22 degrees Celsius to its boiling point? The specific heat of water is 4.184 joules per gram Kelvin. We are asked to find Q, the amount of heat needed to warm the water. We are given the mass, which is 400 grams, and we know that the specific heat of water is 4.184 joules per gram Kelvin. We are also given the initial and final temperature, which can be used to calculate delta T. To find delta T, we subtract 22 degrees Celsius from 100 degrees Celsius, which gives us 78 degrees Celsius, the value of delta T. However, we always want to use Kelvin for our units in temperature. Since Celsius and Kelvin have the same magnitude, if delta T is equal to 78 degrees Celsius, that is the same as delta T is equal to 78 Kelvin. We can use the formula Q is equal to MC delta T. Then we plug in all of the known values to find Q. Therefore, Q is equal to 400 times 4.184 times 78. So Q is equal to 130,540.8 joules.
An example of a constant pressure calorimeter is the coffee cup calorimeter. Because it is unsealed, the pressure inside the calorimeter is equal to that of the atmosphere, which is around 1 atm. At constant pressure, the change in pressure is equal to the heat of solution, which also equals the mass of solution times the specific heat of solution times the change in temperature of the solution in Kelvin. This can also be written as delta H equals MC delta T. In addition, the heat of solution is equal to the negative heat of reaction. This is shown in an exothermic reaction by 1 joule of energy being lost by the reaction and 1 joule of energy being gained by the surrounding solution, or 1 joule of energy being lost by the surrounding solution and being gained by the reaction in an endothermic reaction. It's a practice problem. A student mixed 50 milliliters of 1 molar hydrochloric acid and 50 milliliters of 1 molar sodium hydroxide in a coffee cup calorimeter, and the temperature increased from 21 degrees Celsius to 27.5 degrees Celsius. Calculate the change in enthalpy for the reaction in kilojoules per mole hydrochloric acid, assuming that the total volume of the solution is 100 milliliters, the density is 1 gram per milliliter, and that the specific heat is 4.184 joules per gram Celsius. First thing we want to do is to write a balanced equation to represent our reaction. Here, it's a double replacement reaction that produces water and sodium chloride. The question is asking us to find the change in enthalpy in kilojoules per mole of HCl. The kilojoules represent the change in enthalpy, or delta H. As delta H equals the heat of solution, the equation heat of solution equals MC delta T can be used to help solve this problem. However, we are asked to find the heat of reaction, which is equal to the negative heat of solution. Or heat of reaction equals negative mass of solution times specific heat of solution times change in temperature of solution, or negative MC delta T. Step is to find the values for each of the variables. M represents mass, which we find by using the givens of 100 milliliters total solution and a density of 1 gram per milliliter in a stoichiometric table to get 100 grams of solution. C represents specific heat, which is 4.184 joules per gram Kelvin, or the specific heat of water because this reaction occurs in an aqueous solution. Delta T represents the change in temperature, which is found by subtracting the initial temperature from the final temperature. Both these temperatures are given, and 27.5 minus 21 equals a change of 6.5 degrees Celsius. We need the temperature in Kelvin, and 1 degree Celsius is equal to 1 Kelvin. 6.5 degrees Celsius is equal to 6.5 Kelvin, which is our final answer. By using these values in our equation, we get that the heat of reaction is equal to negative 2.7 kilojoules. The second part of this problem asks us to find the change in enthalpy in terms of moles HCl. To do this, we use stoichiometry to first convert the given amount of 50 milliliters HCl to liters, because there are 1,000 milliliters in 1 liter, and then we use the given molarity of 1 molar or 1 mole per liter to find that there's 0.05 moles of HCl. The last step is to divide the heat of reaction by the moles of HCl. By dividing negative 2.7 kilojoules by 0.05 moles, we get that the answer is negative 54 kilojoules per mole HCl.